For number 5, we've got something that looks pretty different than what we had before. It's not x raised to some positive power like we've had in the past. It's 1 over x. So let's just plug in points and see what happens. 1 over negative 2 gives us a negative 1 over 2. 1 over negative 1 gives us negative 1 over 1. 1 over 0 actually is not allowed. I guess first we'll do 1 over negative 1/2. Remember, when you divide by a fraction, you're really multiplying by the reciprocal of that fraction. So 1 over negative 1/2 is really 1 times negative 2 over 1. But for 1 over 0, we don't allow dividing by 0 in math, because if we did allow it, it would break our system apart, our arithmetic system. So we'll just write doesn't exist there. Fill out the rest of the table. And then for the fact that when you plug in x, you don't get a y, that means we can draw a vertical line there at x equals 0, and we know that our graph won't touch that line, because at x equals 0, there's no y value on our graph. It's called a vertical asymptote, and that vertical line is the line x equals 0, because every point on that line has x equals 0, and every point off the line does not have x equals 0. Scale the x and y axes. Can scale them the same this time. Then when we start to plug in our points, we can see that our graph definitely looks different than what we've seen for the others. There's no y-intercept. And so once we've plotted these 6 points, then we have to think about what the graph looks like. So on the right side of this graph, if you go back and look at the equation of the graph, y equals 1 over x, notice that no matter what x value you plug in, y can never be 0. So as you go out to the right, it looks like the y value should be going down towards the y-axis. Towards the x-axis, but never hit it. Something similar happens over on the left side. It's also useful to think about what happens as you get really close to the x-axis. So like if I plugged in 1 over 10 for my x value, then my y value would be 1 over 1 over 10, which is 10. So the y value would be really large in that case. If I plug in x equals 1 over a million, then y would be positive 1 million. So that's why the y values shoot up as you get close to the y-axis. The y-axis. The shape of this we'll call a rational graph. This is called a rational equation because you've got a polynomial on top divided by a polynomial on bottom. It's kind of weird. The number 1 is a polynomial. There's no y-intercept. As you go out to the right, the y's are going down. Even though they don't go down forever, they level out, they're still going down. And as you go out to the left, the y's are going up.